All right, so we're going to continue looking at solving inequalities and graphing the solution set. Yesterday in our lesson, we looked at how just to solve them, and they were pretty much the same as equations. They just didn't have an equal sign. They had one of the inequality symbols instead. Today, we're going to continue to do that, but there is going to be one small difference between what we're doing today and how we solved equations. And so that difference is whenever we have to multiply or divide by a negative number, we have to do something. And so this is the only difference between solving equations and solving inequalities, and it's right here. If we multiply or divide by a negative number, if we multiply or divide both sides by a negative number, we have to flip the inequality sign. So less than becomes greater than, less than or equal to becomes greater than or equal to, greater than becomes less than, or greater than or equal to becomes less than or equal to. And so the sign itself, as far as is there an equal sign underneath or is there not, that doesn't change. We're just going to flip the direction of the sign. And so that is the one difference between solving equations and solving inequalities. If we multiply or divide by a negative number, we have to flip the inequality sign. Okay, so we will look at some examples and go through those together. All right, so our first one here, 8x is less than or equal to 40. So to solve this, think about solving an equation. We have to get rid of the 8. It's 8 times x because there's nothing in between the 8 and the x, which means we need to divide by 8 on both sides. We divided by a positive number. So when we divide by a positive number, we do not flip the sign. So we divided by positive 8, that's going to stay the same. So it'll still be x is less than or equal to 40 divided by 8 would get us 5. So x is less than or equal to 5, and then we're going to also graph that solution set. So I've got at 5, it's less than or equal to, which means it's going to be a closed circle. And x is less than 5, so anything less than 5 is going to be on the left side. So we're going to have a closed circle and shade it to the left. Okay, so let's look at our next example. I've got c over negative 2 is greater than 7. Another way to say c over negative 2 is c divided by negative 2, remember? And so I'm going to multiply by whatever is on the bottom. I'm going to multiply both sides by negative 2. Since I am multiplying by negative 2, this is where I'm going to flip the sign. Flip the sign because I multiplied by negative 2. And so the negative 2's can cancel out. I'm left with c. Instead of greater than, I'm going to change it to less than. So flip the sign from greater than to less than, and then 7 times negative 2 is negative 14. So I am finished solving that inequality, but make sure you flip the sign because you multiply both sides by a negative 2. So on that number line, at negative 14, I am going to have an open circle because it's just less than. And then whenever I go to shade, I shade based off of the solution set, based off of the answer. So once I flip that sign, I do not care about the starting inequality. I just care about c is less than negative 14. So since c is now less than, after I flip the sign, I need to shade to the left. And so once you flip that inequality sign, you just care about what the solution set is. Okay, so we'll do a few more together just to make sure that we've got this down. So the next one I've got negative 2j is less than 10. I want to get rid of everything on the same side as j, which means I need to times j, I need to divide by negative 2. I'm going to do the same thing on the other side, divide both sides by negative 2. So the negative 2's cancel out. I've got j on the left-hand side, but then remember, I divided by negative 2, so that means I need to flip the sign. And it's going to become from less than, it's going to become greater than, and then 10 divided by negative 2 would be -5. So j is greater than -5, greater than because I flipped the sign, which means I need to flip, or I divided by a -2, which means I flipped the sign. Whenever I graph that solution set, I just care about j is greater than -5, so it's going to be an open circle because it's just greater than. And then now j is greater than, I'm going to shade to the right. So that would be my solution set and the graph of it. Right, and then we'll look at one more together. I've got y over 3 is greater than or equal to 15. So to get rid of that 3, I'm going to multiply both sides by 3. Now I just multiply by a positive 3. So do I need to flip the sign? If I multiply by a positive 3, I don't need to flip the sign. So it's going to be y is still greater than or equal to, because nothing's going to change. 15 times 3 is 45. So that's my solution set. I go to graph the solution set. At 45, I've got greater than or equal to. So that or equal to means it's going to be a closed circle. And y is greater than 45. Greater than means I shade to the right. So y is greater than or equal to 45, closed circle, shade to the right. Okay, so there's 2 more that are left. You all go ahead and do these 2 on your own. Solve it and graph the solution set. Pause the video and answer these 2. Okay, so this first one might have been just a little tricky. So first thing, I've got -x over 2 is less than 9. I want to get rid of this 2 first of all. To get rid of the 2, I'm going to multiply both sides by 2. So the 2's cancel out. Now what am I left with on that left-hand side? I haven't crossed off not just x, I haven't crossed off -x is less than, because I haven't multiplied by a negative number, so it's still less than 9 times 2 is 18. Now, remember back from when we solved equations, do we want a negative in front of our variable before we finish? No, we don't. So think back, how do we get rid of that negative? Well, one thing that we did was we said we could just move it over to the other side. With solving equations, we can do that. We can just move the negative from the x over to the 18. However, remember when I showed you all last week why we could just move it over? There was that technical reason as to why we could do that. The reason was because there is a 1 in front of this x. If there is a -1 in front of the x, how should I get rid of this -1? I should divide by -1. So the -1's cancel out. However, if I divide by a negative number, what do I have to do to the inequality sign? Well, I've got to flip it. So this is going to become x not less than, x is greater than. 18 divided by -1 would be -18. So that is my solution set. So before we graph it, one thing that I want you to know, make sure you understand. If there is a negative in front of the x and we just move it from one side to the other, I also need to flip my inequality sign. Okay, so flip the sign because there was a -1 in front of the x, so technically we had to divide by -1. So now my solution set, whenever I go to graph it, it's going to be at -18. X is just greater than, so it's going to be an open circle, and then x is greater than -18. Greater than means we shade to the right. So that would be our solution set and the graph of it. Okay, so looking at our last one here, -4x is greater than or equal to -20. Well, I want to get rid of this -4. This is -4 times x. So to get rid of the -4 times x, I'm going to divide both sides by -4. So the -4's cancel out. Since I divided by a -4, make sure that you flip that sign. So instead of greater than or equal to, it's going to become less than or equal to. And -20 divided by -4 is going to be +5. So I can still get a positive answer even though I flip the inequality sign. The answer, that doesn't matter. The answer doesn't matter. What matters is, did I divide or multiply by a negative number? And we did. We divided by a -4. And so we go to graph this solution set. We're going to be at +5. X is less than or equal to. That means it's going to be a closed circle. And then less than means we shade to the left. So that's what our solution set is going to look like after we graph it. Okay, that is just solving the solution set. We're going to look at one more that deals with writing and solving the solution set. And so this says the quotient of a number in -6 is less than -2. Well, less than, I know it's going to be a less than sign. Okay, what is the quotient? What operation would the quotient be? Quotient means we had to divide. And so I've got a number. Remember, a number is x. So a number and -6. The quotient of that would be x divided by -6. Remember, when we do equations or inequalities, we don't want to actually put divided by. We want to put a fraction. So x over -6 is less than -2. So that is our inequality. And then we need to solve it. And so to solve this inequality, I would get rid of the -6. To get rid of that -6, I need to multiply both sides by -6. So the -6's cancel off. But also remember, what else do I have to do? Since I multiplied by a -6, a negative number, I need to flip the inequality sign. Making sure we don't forget about this. I'm writing it down every time. Flip the sign because I multiplied by a negative number. -2 times -6 is +12. So x is greater than, just greater than, +12. If I were to graph this solution set, what would it be? It would be an open circle because it's just greater than, no equal to, and it would be shaded to the right because x is greater than 12. And so that is writing an inequality, flipping the sign, and getting the solution set. Okay, so I think we've got down at least one step inequalities, but everything that we need to know about solving inequalities, we've pretty much covered at this point. So go ahead and work on these problems with graphing and solving, solving and graphing the solution set. Now that's all you have to do. If it says to do anything else, don't worry about it. Just graph the solution set after you solve that inequality.